Okay, in this last section of 4.3 slope, 434, calculate the rate of change in applied situation. Obvious applied situation is the word problem. Rate of change, by the way, rate of change actually is the same as slope. Slope, rate of change, the same formula. The only difference is the slope. You don't have a unit because your numerator denominator will cancel same unit. That will cancel the unit. Rate of change will be a different unit of the numerator and denominator. It's like 3 miles per hour. 3 miles per hour. OUR. You have a different unit here. You cannot cancel each other. That's why we give it a different name, rate of change. But the formula exactly the same. You are using y2 subtract y1 divided by x2 subtract x1. But they have the different unit. Okay, we give it a name, rate of change. Same way to calculate. Now, we are getting into our checkpoint number 5. This is our page number 253. In that example, let me read the problem. Checkpoint number 5. This is our page 253. Checkpoint number 5. Use the order pair in figure 4.28 on the previous page, right here, to find the slope of the green line for man. Green line for the man. Express the slope correct to 2 decimal places and describe what it represents. Describe, this kind of thing is using English make sense. Describe the situation. Okay, in that example, we have a graph on that page 252. On the horizontal line, the year. They show that pretty clear. 1990 at the 0 year, 1995, 2000, 2005. And the vertical line here show that the number living alone. For the green line, okay, this only shows one green line. The very exact point here, 1990. 1990. We have a y value of 9 here. This is 12. This is 3, 6, 9, 12. Unit is I would say that's a million people. In this year, how many still living alone? Okay. For the very first point, we are using this point. Obviously, they even label the point for you. In the 1990, the man still living alone, you have a 9, meaning 9 million people. Men live alone. In the year 2005, they have a point here, 2005, 12.7. This you don't need to make any guess for that. They are asking for what is the rate of change. What is the rate of change at these 2 points? I want you to describe in a meaningful English. So the same way, the rate of change. This is a very good example. Rate of change, ROC, or you can use M, equal to Y2, 12.7, Y1, 9. X2, 2005, X1 is 1990. As you can see, the same way as we do the slope. You can see here, you can use your calculator right away, but here if you reduce this, 3.7, 2005 subtract 1990 will be 15. And then use your calculator. So the most advanced calculator gets you see all the formula here. 3.7 divided by 15. Push the button, you see the number is decimal to the 0.2466 that will continue. Okay? And the instruction in the book says find the slope correct to the 2 decimal places. 2 decimal places, meaning you want to keep this decimal. So the next digit is 6, you add 1 to here. So round it. This is approximate symbol, 0.25. Okay? And then use English to describe this. What they said. Describe what it represents. What this rate of change means. As you can see, the denominator is the year. You can see YEAR. The numerator is the man living alone in million. So that's man living alone in million. So the number is 0.25. How are you going to say it? You're going to say the number of men living alone increase at a rate, because this is positive, increase at a rate of 0.25 million per year. Men living increase by 0.25 per year because the slope is positive, like this. If they're decreasing, you can use the decrease, like this, falling and decreasing. So that's how we use English to describe this with the unit here. Okay, that's what we call the rate of change. Okay, this is the end of our 4.34.